All right, so now we're going to solve logarithmic functions, equations. Remember last video, we solved exponential equations using logs. You could have graphed them as well and solved for an approximate answer. Remember, we were going for the exact answers before. So it did get kind of complex. I'm assuming that we're going to have more questions on this, and you might have some questions that maybe in our office hours we can talk more about how do we solve those kind of questions, and those are probably the hardest kind of questions you might see. These kind of questions, though, they're not really that hard, but the main part for these is just always check to see if our answer makes sense. Because remember, sometimes you take the square root or the square or something, you might be adding an answer that actually doesn't make sense in the original solution or the original equation. So we get something called an extraneous solution. So when we solve this, we want to solve for x. We want to round it, in this case, to the nearest tenth. We're not looking for exact answers for this one. So we're going to follow our log laws here. Now, there's a few different ways to do this one. If the logs are the same, just like how if our base is the same and both sides is like 3 to the x and the other one's 3 to the 2, then x equal to 2. We can drop the base. Here, because the logs are the same, there's no coefficients or anything. If there is a coefficient, just get rid of the coefficient and then solve for x. If we get rid of the coefficient, then drop, in this case, we're going to drop the base. So for these two logs to be the same, what's inside the two logs have to be the same. So we could drop our two bases, rearrange them really quickly here. So just subtract over the x, subtract over the 2, divide by 2, -4. Okay, so we have x is equal to -4. Then we go back and double check. Okay, so we have this graph here that x is equal to -4. We go back and say, what were my restrictions? Well, the first one here, this side here, x just has to be greater than, does that be greater than -2/3? On the next one over here, x has to be greater than 6. Uh-oh. So we just solve for x, but the x doesn't fit these restrictions that we have here for our two logs. If I put this -4 into, say, the one on the right, -4 minus 6, I get -10. I can't take the log of -10, and we're done. So technically, there's no solution. So this answer here is an extraneous solution. I'm just going to write that down. So overall, there is no solution to this question. Okay, the extraneous solution is not a solution. It's a solution that doesn't work. Yeah, looking pretty good. Okay. Hopefully you don't get that all the time. Let's check out this next one here. So I can't just drop the bases here because of the coefficient, but you could use our log law to start off with. So we can bring that coefficient up as an exponent. Now I can drop my bases because they both have log base 3. So this x to the squared is equal to 4. I can take the square root of 4. You get plus or minus 2. Remember, you get the 2 plus or minus. But you'd probably want to double check both of those solutions and see if they work. If I look back up here, my restriction was x just has to be greater than 0. Like I look at this here. I can't take the log of 0 or negative numbers. That's just an x by itself inside that log. I can't do anything on the other side. The other side just works. So I notice that this is an extraneous solution. So I only have one answer. I can't spell extraneous for some reason. And x equal to 2. Okay. That makes sense. Okay, the next one here. Remember, always go back to the original equation to solve, see if there's extraneous solutions. Before I can drop the base, I have to make sure this is a log equal to a log. So I'm going to look at this one here and say, oh, I'm adding these two logs together, so I can combine them together by multiplying what's inside them together. And now I have a log equal to a log here, so I can drop my logs. And then I have, well, I should know what that is, but I'm not going to deal with that right now. So 7. Then you go back to the top, 7. Like I look at my restrictions here. The only restriction I have is here. This cannot be a negative number inside the log here. So x has to be greater than 0. So this answer should work out nicely. All right. So you can only drop the logs if the base is the same and if it's a log equal to a log. So if I see this, here's a log, 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 I can't just drop these logs. I got to combine them together first. So this is log base 4. This is x plus 1. And then on the bottom, I have 2x minus 3. And then over here, I have log base 4, 8. Okay. Now, and I got log equal to a log, so I can drop the 2 logs. So I can make it equal to 8. And I just want to solve for x. By doing this, I've also added an extraneous solution that probably won't matter too much, because if that's equal to 0, I also have a 0 problem up here anyway. But I can multiply the bottom piece up to the other side times that 8 into the brackets and solve for x. I'm going to minus over the x and get 15x. I'm going to add this over and get 25. So I get 25 over 15, which would be 5 over 3. Okay. So just double check to see if that's going to work for us. 5 over 3. So I might as well just double check here. So is this an extraneous solution? So I want log base 4. Now to check for extraneous solutions, it doesn't matter if it's log base 4, but I just want to see if it ends up being the same thing. Log base 4 is good for just checking the solution. So here I'm adding 1, so that's going to work just fine. Then I'm going to minus the other log, base 4 as well. And then I'm going to 2 times 5 over 3 minus 3 and my bracket. Looking good, so I got 1.5. Okay, so is log base 4 of 8 1.5 as well? Yeah. So the left-hand side equals the right-hand side. There was no problem. So we verified our answer. Looks pretty good. Okay. So what are we going to do in this one? We're going to do the same thing. Or this time we're going to multiply what's inside these 2 logs. This is log base 3. We have x. I'm going to write this out. X. I'm going to multiply it this way. Let me just get rid of that. Fix that up. Okay. So I'm going to multiply what's inside. Combine to 1 log. This is log base 3 of 6. So I can drop my bases now. This is going to be x. I'm going to write it out. X minus 1. Now to solve for this, I realize this is probably going to be a quadratic at the end. When I multiply the x into the brackets, I get x squared minus x. The x squareds are not going to disappear all of a sudden, so let's just make it equal to 0. And let's factor this if I can. It'd be great if I could. What multiplies out to -6 and adds to -1, so -3, +2. So x is either 3 or -2. Now sometimes a negative x could work if they just happen to work up here, like if this was a negative x in here. This might work out pretty good if there was the math in there ended up making it positive. But I realized that this is not going to work in this piece here. So if I put a -2 there, I get the log of a negative number. That's not going to work. The log of 3 should work, and the log of 3 minus 1, log of 2 should work out. So that's my answer. And you can verify it like we did with the previous question. You plug it back in to all the x spots, put a 3 in every spot, and see if it works. You can see they're not too bad. They're pretty easy. Now, there are multiple ways of solving some of these questions. I'm going to show you 2 ways to solve these ones, and you pick the way you like. I'm not going to limit you to one way. Now, if one side is not a log, so one side of this is not a log, so I can't drop the base unless I introduce the base. So that's one way to do this question, where I can say, okay, I can introduce this base. I can say, oh, 1. 1 is just log base 3 of 3. So now they're the same. So I can drop my base. Maybe factor this. It seems like I could factor this. Yeah, maybe I can. I'll multiply this out to 3 is 3 and 1. I need to add to a -2. So x is equal to 3 and -1. Then I want to put that back in here to see if that could work, and maybe both of them work. I see I have a negative x value at -1 there, but does that work in this equation here? Okay. So maybe it does. Let's just double check here. So what's -1 squared? So that's +1. 1 minus 2 times -1, so that's +2. So that's 1 So that's 1 plus 2. That's 3. So log base 3 of 3 is 1. So that does actually work out. And if I do for the 3 there, should maybe work out to 3 squared minus 6. 3 squared minus 6. So 9 minus 6 is 3. Log base 3 of 3 is 1. So both those work. Now, another way to do this kind of question is if one side doesn't have a log, why not just put it into exponential form? So remember when we did that, we could switch these two. My base is 3, so this would be 3 to the power of 1, x squared minus 6. Oh, it's exactly the same equation that we just solved on the other side. Make it equal to 0 because it's a quadratic. Factor it out. I don't know why I'm rewriting the steps again. X equal to 3 and negative 1. So you could just reintroduce the log on one side and then drop the logs. And you might see that there's question C down here. Now that might be a useful step. Or just change it in exponential form. So in this situation here, I could just reintroduce the log or I could change it to exponential form. But before I do that, we're going to have to combine this into one log because the exponential form thing doesn't work. Or dropping the base doesn't work as well, unless we have a log equal to a log or one log on one side. Oh, I don't know why I'm doing the divide rule here. I'm talking too much while I'm doing this. Sorry, listen, excuse me. We're going to multiply these two because they were adding. Oh, I'm going to sneeze. Excuse me. Is equal to 1. Yeah, so we could just do our log rules here. So this is 5 to the power of 1 is equal to x plus 1, x minus 3. So that this is me just changing it into exponential form. So the base is 5. I'm going to switch these two sides. So 5 to the 1 is equal to whatever is inside the log. We're going to have to do a little bit of math. Either way, we would have done math. Or, of course, we're doing math right now. But we have to change it into a regular quadratic, so we're going to do the distributive property. So x squared minus 3x plus an x minus a 3. And make it equal to 0. What do we get there? So we get minus 8. Can I factor this? It's always kind of convenient that we get quadratics that we can factor. Otherwise, we're going to have to use our, or you can't see it. It's over there somewhere, a quadratic formula. So what multiplies that to 8? So 4 and 2. That's got to be negative. This is going to be positive. Okay, so x has to be 4 and negative 2. Then we go back here and double check. Oh, if I put a negative 2 into either one of these, I get a log of a negative number. So that's not going to work. So my only answer is probably going to be 4 in this situation. 4 minus 3 is 1. That works. And 4 plus 9 is 5. Log 5 to 5 is 1. The log of 1 is 0. So 1 plus 0 is equal to 1. So no mental verification there. This works out. Just erased a part of my answers there. That's not what I want to do. That's what I want to do. Okay. I'm just going to rewrite this so it's in my notes too. Okay. Now, if I have a half here, there's two ways to do it. Isolate for the logs, put the other log on the other side, solve for that. You can reintroduce the log, do that as well. Either way, you probably get the same solution. Here's, I got 2 spots here. Might as well try it out, see what happens. Okay. Let's do the first one. Let's move the logs to one side and get the logs all by themselves. So I'm going to minus over the log 9 of x minus 1 and leave the half on this side. Minusing these two logs, I'm going to combine them together. So I'm going to divide these two. And I can change this into exponential form. So this would be 9 to the power of a half. This is equal to 7x plus 1, x minus 1. All right, well, that's just 3, because remember the half, an exponent of a half is just a square root. All right, and then we're going to solve. So I'm going to multiply up the bottom piece. I said for x here. So I'll multiply the 3 into the parentheses. I run to the bottom of my screen. I guess I could scroll here, just give ourselves a little more space. Okay. There, I'm going to minus over this 1. Divide both sides by 4, get -1. Okay. Seems pretty good. This is looking up here. So the reason I paused is like, does this -1, does it actually work? Or did I mess up on my steps down here? Let me just double check. I'm going to minus that over, minus this over. Yeah, it seems like it worked. But the problem is it doesn't work because -1 in this first, or the second one on the right side here, -1 minus 1 is -2. Doesn't work. So it looks like we have no solutions. I just want to see, do we get the same answer if I tried the other way? So the other way I wanted to try this is, what if I reintroduce the log? So half is the same as a half times log 9 of 9. And then I'm going to go plus log 9 of x minus 1. Okay. So this would be log 9 to the half. So I'm going to take that coefficient, make it an exponent. You can kind of see there's already a pattern, like that is now going to be a 3. Okay, and then I'm just going to rewrite these two things. I haven't done anything to them. So this would be log base 9 of 3. Log 9 of that. Now I'm adding these together so I can multiply them together. So this would be log base 9 of 3x minus 3. So I'd multiply them together. I kind of skipped a simple mental math step in there. Now they're both equal to the same number. So I can make them, or both have the same base, sorry. I can drop the base. Do the same steps we did before. So I got 4x minus the 1 over. Hey, look at that. It doesn't work again. Okay. So both ways give us the same answer. Okay, so what we're going to do in the next video is we're going to talk about how do we use these to solve, algebraically solve for a question that we usually do with the graphs before. These are going to be the word questions. Okay, I'll see you in the next video. Bye.